So when you are factoring, you always want to check for the greatest common factor first. So for example, when you take a look at problem number 1, the coefficients 9 and 10 do not share a common factor other than 1. However, if you look at your variables, you have 3 x's in the first term, 1 x in the second term, so you can factor out an x. You have a y squared and you have a y to the third, so you have 2 y's in common. So your GCF in problem number 1 is going to be xy squared. Remember, when you do GCF factoring, you're dividing it out of each term. So that's going to leave you with a 9x minus 10y. Always check inside the parentheses to see if you can factor further, which you can't. So now if you take a look at number 2, again, still applying the same factoring techniques except you're using trig functions. Notice your coefficient 4 and 2. You can factor a common factor of 2. You have a secant squared in the first term, 1 secant in the second term. So another part of your GCF is going to be a secant theta. You have a tangent to the fourth and a tangent squared. So you can pull 2 tangents out of each term. And again, remember, you're dividing out this GCF. So 4 divided by 2 is a 2. Secant squared divided by a secant is going to leave you with 1 secant. Tangent to the fourth divided by tangent squared will give you a tangent to the squared theta. Minus, notice you factored out this entire GCF, so anything divided by itself is going to leave you with a 1. So after you check for a GCF, if there's no GCF, you have to count your terms. If you have 2 terms, you've got to look to see if it's a squares or cubes. Notice in number 3, 25x squared minus 9y to the fourth is a difference of 2 perfect squares. So we can factor this as 5x minus 3y squared. Remember, you just take the square root of 9y to the fourth, which is why we write a 3y squared. And it's the sum difference pattern. One set of parentheses has the minus, the other one has the plus. And that's how you can factor a difference of 2 perfect squares. Remember, if this was 25x squared plus 9y to the fourth, sum of squares is always prime. You cannot factor a sum of squares. So looking here, you've got an 81 cosecant to the fourth theta minus 9 secant squared theta. Always check for the GCF first. You can factor out your GCF of 9 first. Again, don't stop. You have to look inside your parentheses. 9 cosecant to the fourth is a perfect square. Secant squared is a perfect square. So you can, again, factor using difference of squares. So 3 cosecant squared theta minus secant theta, and then 3 cosecant squared theta plus secant theta. Remember, if it makes you feel better, you can always rewrite this in terms of x's and y's, and then just do a substitution. So 81y to the fourth minus 9x to the fourth. You can factor this in terms of x and y, and then just bring your cosecant and secant back into the problem later. Looking at number 5, again, no GCF, but you have 2 terms. This is a sum of cubes. So remember, the way you factor sum of cubes is you always use your SOAP. That helps you remember the pattern of your signs. In the first set of parentheses, it's always the same sign. That's what the S stands for in SOAP. The O is the next sign in the trinomial in the second set of parentheses. That's always opposite of what's in the original problem. So this is your same sign, opposite sign. The AP represents the last sign, which is always positive. So now that you've established your signs, now you can remember the other part. You do cube root, cube root. So the cube root of 64x to the fourth is a 4x. Be careful, 64 is not only a perfect square, it's a perfect cube. When you're factoring cubes, you want to do the cube root of 64. Cube root of 27 is 3. So there's your cube root, cube root. This term is going to be square. You're going to square your first cube root. That's going to give you a 16x squared. So cube root, square. This is going to be a product. Multiply your 2 cube roots together. 3 times 4x is a 12x. And then square your last cube root, which is a 9. So remember, it's going to be cube root, square, product, square. Again, whether you sum or difference of cubes, you can factor it. So like for number 6, again, 8 sine to the third theta, it's a perfect cube, so is 125. So you can set up your 2 sets of parentheses. Again, apply your SOAP, same sign, opposite sign, always positive. cube root of 8 sine to the third is going to be 2 sine theta. Cube root of 125 is 5. Product, square your first cube root. That's a 4 sine squared theta. Product, multiply your 2 cube roots together. That's going to give you a 10 sine theta. Square your last cube root. That's going to give you 25. This is a trinomial. Leading coefficient is positive 1. So you want to find your factors of negative 35 that add together give you negative 2. So 7 times 5 is 35. So I can write this as a minus 7 plus 5. Now, again, I know the square root of x squared is x, so I'm going to write it x here. But because of this y squared, when you take your factors of negative 35, you're actually looking at factors of negative 35y squared. So this is just going to be a negative 7y and a 5y. Negative 7y times 5y does give you that negative 35y squared. Again, with a trig function, it's a trinomial, 1, 2, 3 terms. Leading coefficient is 1. Factors of negative 5 add together give us negative 4. The magical pair is a negative 5 plus 1. And again, the square root of cosine squared is just a cosine theta. Now, when you have a trinomial and the leading coefficient is not equal to 1, this is where a lot of you do this little x, and you multiply your leading coefficient and the constant together. So when you multiply 15 times negative 2, which is negative 30, you want to find the pair that adds together give you 7. So you look at the coefficient of x. So the numbers multiplied together to give you negative 30, but when you add them together give you 7, would be 10 times negative 3. So now what you're going to do is you're going to rewrite this trinomial as 15x squared plus 10x minus 3x minus 2. So basically what you're doing here is you're going to rewrite this 7x into the factors of 10 and negative 3, because 10x minus 3x is a negative 7x. Now what you're going to do is you do factoring by grouping. Parentheses around the first two, parentheses around the last two terms. Now you do GCF out of your first set of parentheses. The GCF you can pull out here is going to be a 5x. And that's going to leave me with a 3x plus 2. Look at your second set of parentheses. You already have the 3x and the 2, no common factors, but you can factor out a minus 1. By factoring out a minus 1, you're just going to change the signs of what's inside your parentheses. For grouping to work, remember, these two parentheses have to be identical. So to finish factoring, you're going to factor out that 3x plus 2 again. Do GCF factoring again. So when I yank out the 3x plus 2, what's remaining is my 5x minus 1. So there's my factored form. So looking here at 21 sine squared minus sine theta minus 2. Again, it's a trinomial. The leading coefficient is not equal to 1. So just like in number 11, you have to multiply 21 times negative 2, make your x again. 21 times negative 2 is a negative 42. And again, look at your coefficient in front of the middle term. That's a negative 1. So you want to find numbers multiplied together to give you negative 42, but when you add them together, give you a negative 1. So the factors that are multiplied together to give you negative 42 would be negative 7 and a positive 6. So negative 7 plus 6 is a negative 1. So I can, again, do my grouping, rewrite this negative sine theta into negative 7 sine theta, 6 sine theta. So 21 sine squared theta minus 7 sine theta plus 6 sine theta minus 2. Now do your grouping. So the GCF I can pull out of the first set of parentheses is a 7 sine theta. That's going to leave me with a 3 sine theta minus 1. Don't forget to write the minus 1. The GCF you can pull out of the second set of parentheses is a 2. So that's going to give you a 3 sine theta minus 1. Notice those parentheses have to be identical for grouping to work. So I can pull out the 3 sine theta minus 1 times 7 sine theta plus 2. That's factoring by grouping. Again, remember, this is a binomial. This is a sum of squares, always prime. You can never factor a sum of squares. This is another sum of squares. This is also prime.